All right. So the lesson's going to be we're gonna simplify trig expressions using basic identities. So the basic identities, no formal training right now, just what we've been using. So we know tangent is sine over cosine. We know secant is 1 over cosine. Those sorts of things. We're going to learn more as we go, and the Pythagorean are going to be the biggest ones. But for now, that's what we're going to do. So let's start off by analyzing. We're going to start off our first example. Just an example. Is going to be we're going to simplify cosecant of an angle multiplied by the sine ratio of that exact same angle. All right. So as you get started, one of the techniques, and they're obviously going to build, but one of the techniques is to think about things in terms of sine and cosine, right? So you and I know cosecant can be written as sine, right? So let's write that as 1 over sine, being lazy with my language, sine of theta, multiplied by the sine of theta. Now, I'm going to just put the over 1. You absolutely positively don't need to do it. But what I will say is a lesson I could give you is just be meticulous about keeping things in numerator and denominator, because it will make a big difference later on. What our goal of this is, we're trying to just simplify it. Really, if you can get it down to one term or one trig ratio or something like that, that's kind of where you're going. I'll kind of guide you as we're going in, like the beginning of the lesson, beginning of the unit, kind of just out there. We don't know what we're doing. We're just trying a few things. So right now, there's not much purpose. Let's get this down as simple as we can get it and see what happens. So you and I can really see we're going to multiply the 1 times the sine and the sine times the 1. So that's just going to be rewritten as sine of the angle over sine of the angle. Anything divided by itself, it's going to be 1. Well, that's kind of interesting, because so you're having a function that holds angles as inputs, and when I divide, so what that's saying is the cosecant of an angle multiplied the sine of that same angle will always be the number 1. And you can test me out on your calculator sometime later if you want to try. And I can even show you, just show you with a quick example. Let's just pick something, sine. So let's pick a nice easy one. Let's pick pi over 6. So let's do the cosecant of pi over 6 multiplied by the sine of pi over 6, right? So that's cosecant of theta times sine of theta. That's exactly what we had. And we said that number should be 1. And it doesn't matter if I put pi over 3, pi over 4, 0.2 of a radian. It really won't matter. It'll always be 1. But the reason being is because they're reciprocals of each other. Let's just start off with the sine of pi over 6 first. I'm just going to do it because we're on the video. So the sine of pi over 6, we all know, is the y height of pi over 6. So that's going to be 1/2. Just as add tumultuous uproar. So if the sine of pi over 6 is 1/2, what's cosecant of pi over 6? 2. Well done. All right, 2 over 1. So then you've got, 2 times 1/2, or 2 over 2, or however you want to analyze that, that is going to be 1. So even though the angle's changing, the result is always going to be a constant 1. That really has nothing here or there with the lesson. It's just an interesting fact that, there are going to be several trig expressions that when I put in angles, they will simplify down to being a constant. All right, and we'll see it as we develop. Keep moving through. So let's do one right now. Let's do a second one here. Let's do number 2. Let's do cotangent theta divided by secant of theta. All right, so there are going to just be many different ways to do this. Your neighbor may do it different than you. I might do it different. I might do it one way today and a different way another day. But the rule is, as long as you perform legal algebra and true identities, you can't go wrong, right? So basically, by the time you get to the test, I'll have to grade each person's. There's no like a key for everything. I just have to check all the steps, and my term will be as long as you used mathematics we use here on Earth, you didn't use any Martian math and things that don't make sense, then you'll be fine, and you'll work through it. So let's just take the lead on this one. I'll do this one, and I'll have you do the next one. So I'm just going to go ahead and I'm going to rewrite this as two separate factors right now. Instead, you can see it as one term and like a quotient. I'm going to write it as cotangent theta multiplied by 1 over secant of theta. And like I said, once you get good and you do all these things, I'm not saying what's going to be required. I'm just saying I can read legit true math. When you can start seeing faster and faster, then you can do that. But for now, we're just going to go, kind of one step at a time, a little slow. Let's see what we want to do. Many ways to attack this. We'll just do this one. Now, I'm going to start writing that as sines and cosines, right? Because as in a student, you're more familiar with sine and cosine than you are with anything else, right? So that's one strategy, but it's not the only strategy, and you will get better, and it'll be better. But I'm just not locking us into that. But for today, cotangent is x over y. It's adjacent over opposite, so that becomes cosine over sine. Okay, so that's my cotangent. This is my y, my sine, and my x, my adjacent. That's my radius. Cotangent, well, let's see. So of that angle, tangent is opposite over adjacent, y over x. So cotangent is adjacent over opposite, so on and so forth. That's my cosine, that's my sine. There we go. So then I can rewrite secant. Secant is r over x, and it's 1 over. So that's like saying, here's my thinking box over here. It's not in my problem. I know I've got 1 over secant, and I know secant is radius over x, right? So maybe they're doing too much for you there. So just the reciprocal of that is x over r, and we know that to be cosine. Or 1 over secant is cosine, however you want to think about it. There's many ways to get there. So now we've got, let's just put the 1 in there because it's not necessary, but so you can see you have a product. Now we're just going to multiply that by that and that by that. Let's see, what does that give me? That gives me cosine times cosine, which is cosine squared theta over sine of theta. And for now, we're just gonna stop there. There's not really, see, there's ways to go, and when you're looking at them for other purposes, and in calculus, you'll know where you want it to be, and you'll shape it and manipulate it into that. Then you'll be able to use a certain formula, and you'll be able to do stuff. So it becomes important then. For right now, we're just playing. We don't really know what we're doing. We have no purpose for that. We're just kind of getting it down as simple as we think, and that looks pretty good right there as one term. As another way I could write that, but we'd already had it. It'd be, that would be, that could be written, many ways. So let's just, I'll show you what I'm talking about instead of just talking. So that could be cos over sine times cosine. And that cosine over sine would be my cotangent times my cosine. What did I start with originally? Basically cotangent times cosine. Yeah, so it's like you're just going round in circles. I mean, there's really, so the purpose for this first section is just getting used to changing the form, moving around. There is no big, there will be no big epiphany at the end of it, like, oh, I've got this to a point. Just for a day or two, though, you will have, it will come very shortly. So why don't you try this one? I'm going to try my new pausing the recording feature. So I'll stop this after I give you the problem. So let's do cosecant theta times cosine theta over tangent of theta. All right. And how about this? It's give you some purpose. Let's give you some purpose. Write or simplify write as one trig ratio that is squared. All right, so basically your options are going to be sine squared, cosine squared, tangent squared, secant, something like that. So and I'll want to see, kind of your work along the way, and I'll walk around. Let me try and pause this recording. I think. No, let me see. I may be still recording while I'm doing this. All right, I cannot find the pause. So what I'm going to do is I'm going to do the next example. I'm going to scroll through, and then anyone that's watching the video, I'll have to figure out how to pause it in the middle. I'm going to scroll through. I'll do the next example. We'll do another one. And then those that are watching the video can pull down and try that example. Or you in the room, once I've done the next example, you can come back and do this one. Okay, because it was just like the one before it. So let's go ahead and do the next example because I want to keep... Go ahead. I've tried. Stop sharing, I think, will stop the whole recording. I'm trying. I tried to do that. And I think if I was in a Castify window, I might be able to. I am not sure. I did it when I was playing around, and I'm muddled up. I know, right? You should be able to touch it. I should be able to stop it. Did you see another one? Okay. I don't know for right now. We'll figure it out. We'll play around afterwards. So the next example, we're going to be factoring. So we can use our factoring techniques to help us factor trig functions. So when I give you, let's give a warm up here. This is a warm up. So if I gave you x squared minus 9, you'd be like, oh, I had that in algebra 1. That was the easiest. That was the first special technique they gave me. That's the difference of squares. So x plus 3, x minus 3. Now at this level, I want you to get used to the term. That's a conjugate pair, because that technique's going to be used a ton. So a conjugate pair, we'll use that throughout. So that just means same. So the x, the 3, the x, the 3. The only thing that's different is the sign between them. Now, that has a lot of properties. You've made your eyes drop out in imaginaries with that. You've rationalized denominators with that. We're going to do other things in trig with that. So that conjugate pair, just knowing that word is going to be useful. And we use it in calculus a lot too, to simplify. So that warm-up is simple factoring. Now, let's just take that and use that same technique. But if I gave you something else that was squared, minus 9, then we could deal with that in the exact same way. That is a difference of squares, a product of a conjugate pair. So that means, let's see, I've got the square root of my first term, tangent of x. So the square root of x squared was my x. Yeah, my square root of x squared was my x. Square root of tangent squared is tangent. So tangent plus 3, tangent minus 3. So same thing, term, same, plus and minus. So that is factored as much as we need it for now. We're not setting equal to anything, so we're good. So we have that, and I did lie. We have one more. That was a two-term quadratic type. So you've just got, and you've got an x squared. So you've got these different types of quadratics. And you've got ax plus c, and then you've got ax squared plus c. Then you've got ax squared plus a linear term plus a constant. So let's look at one of those in the trigonometric form. So that would be something like, let's see, I'm going to have my lead squared term. So that's 1 cosine squared plus 1 cosine minus 2. So it's exactly like if that x squared plus x, that's the same thing we were thinking about. That would be the same thing as x squared plus x minus 2. Everyone in here will be very happy to factor that down to, let's see, what multiplies to negative 2. Oh, that is plus 2 and a minus 1, right? So that looks good. We've got perfect factors. Same thing goes with a cosine. So let's see, let's multiply. So I've got cosine of x plus 2, cosine of x minus 1. Let's just pretend it were on my test, so it's well worth checking, right? So let's see. What happens when I do cosine times cosine? That gives me cosine squared. That's good. What about cosine times negative 1? That's negative cosine. Cosine times 2. Well, that's adding 2 cosines to a negative cosine, which gives me the positive. And then I do my negative 1 times my negative 2, giving me my negative 2. It does. On the original, in the factoring. Yes. So that is it. All right. So we're going to factor. We're going to break things down. For today, what I'm going to do is I'm just going to give you a formula sheet, and I'm just going to put a few on the board, and we'll do it. Tomorrow, I'll break down some more and show you a little bit more, and then give you an actual worksheet to do. Okay. So we're going to go up here for, there you are. Right here between the next few minutes, and I'm going to stop the recording. You're going to write this trig function, this expression, as 1 trig ratio squared, and you're just going to use correct replacements, which are known as identities, along the way. Okay, so now I'm going to stop the recording, and I'll take any questions you have.